So for day one of making the electric motor, I did some research about some simple electric motors, and I learned that there's two different types of magnets. One's a permanent magnet, which is these donut magnets. This doesn't need anything to become a magnet. And there's also some electromagnets, which needs a circuit and needs energy from something else to become a magnet. And the electromagnet in this case is the coil that I made with the copper wire. So I made a coil with a copper wire. I put a marker in the middle so that I could get a lot of current in the middle right here in this little sphere. So that creates an electromagnet. And from other examples of simple current is that this electromagnet creates a force, and then this attracts a part of that electromagnet, which makes it in turn spin. Also for day one, I started to figure out what I wanted my design to be for my electric motor. So I went down to Mr. Palmiato's room and I used a drill press to make a little area for the battery to go in. So the battery just sits right into the wood block, so it doesn't move around. It's easier to work with. And I also know that these paper clips that Mr. Waz gave me also need to be connected to both sides of the battery, and somehow I need to figure out a way to connect the coil to these to create a circuit, which creates the electromagnet. So for the coil, I knew that there was an insulator for the copper wire. It's the little red outside, so I had to use a sandpaper to sand off the edges, which you can see a little bit. So it's just copper wire, and this will allow a current to flow through it. And to check, I used a voltmeter, and I went to the continuity to see that a current can flow through this. As you can hear with that sound, continuity can go through this coil. So to balance this, this copper wire is a little bit flimsy. To balance this, I'm gonna try to cut off a piece of the paper clip, which you can see is this, and then wrap the copper wire around the little piece of paper clip, so it's a little bit stronger than just the copper wire by itself. So I wrapped the copper wire around the piece of the paper clip, as you can see there, and I'm going to reinforce it with some electrical tape so it's just a little bit more stronger than what it is right now. All right, for day two of the electric motor, I have started to work on the balance problem of the motor. So just like I said on the first day, I cut a piece of my, the paper clip and used it to strengthen it. And instead of using electrical tape to strengthen it, I soldered it, which is melting a different metal to combine the copper wire and the paper clips. And I did it on both sides. And for the paper clips to hold the coil above the magnet, I'm gonna make these paper clips closer together so there's less length for the paper clip to hold for the coil, so it'd be a lot more stronger. Also for day two, I did some extra research about how an electric motor works, and there's this certain thing called a brush, and what it does is that it flips the current in an electromagnet, which is the coil in this case, and you need this because if you didn't have a brush and it just had the same current the whole way through, positive and negative, the same way, then only one side of the electromagnet would attract to the permanent magnet, so it would never go in a full rotation. To solve this problem, I got a small piece of electrical tape and put it on one half of the piece of the paper clip, and I had a hard time getting the electrical tape to stick to the paper clip. So what I did is I used a blow dryer for hair, and I heated up the electrical tape to make it to stick onto the paper clip more or better than it was. So this is the electric motor running. the full power that it can at this point. I can do a little bit more balancing, and I can also get the magnet a little bit closer to make the electric field a little bit more stronger. Other than that, this is as fast as it goes at this point from the upgrades from day 2. So for day 3, also known as May 1st, the day was used mostly for changing the design of my electrical motor. While I was going around 500 RPMs, I knew that it could go a lot faster. Some of the changes that were made today were the paper clip that held the coil when it was spinning. So before the paper clip, the bottom was where it twisted, which made it like not very smooth when the coil was spinning. So instead I flipped it, so it was at the bottom. It was a lot more smoother when it spins. The second one was the connection between the battery and the paper clip. The current was kept getting lost because the connection wasn't very good. So I used a needle nose plier to twist it so it would go around the battery better. It would be more connection. And I was using electrical tape to connect it. The third one was when the electrical motor was spinning, the paperclip would either attract to the magnet and it would get the coil would stop spinning, or it would go up in the air. So what I did is I took a drill and a drill bit, and I drilled holes into the wood. You can't really see them, but I drilled holes so that the ends of the paperclip could sit inside of the wood block so it wouldn't move or attract to the magnet. Also for day 3, before I had 2 pieces of electrical tape on each side of the connection between the paperclip and the coil. When I only really need one brush, as it's called, to flip the current in the electric motor. So I only have one on it now. Also for day 3, I was testing with a stronger magnet to see what spot on the piece of wood is the strongest when the motor's spinning, and it switches all the time. So every time I test with my motor, I have to move it to different spots. So most of the time it's better if it's just sitting there, but other times I need the magnet to be up on the edge, like under the coils, and it spins faster, but it just changes every time. It's the magnetic field, and it's different every time because of the coil when it's moving around in my bag and stuff. So on day 4 of the project, working on the project, I ran into a big problem, which was my armature broke. It was before the paperclip and the solder, and it was just where the copper wire was. I think this happened because when I kept testing it, and I think it was heating up a lot, and the copper was heating up, it was also bending a lot because the magnet was getting really strong. So I think the copper wire started to like lose its strength, which is why it broke. So my new design was I pushed my paperclip through the middle of the coil. You kind of can see it there. It's like in the middle, and then it goes through the very opposite end. So it's a lot stronger, so it doesn't bend as much. And then I coiled the copper wire around the paperclip again, and I soldered it, and it came out a lot stronger. While it didn't go as fast as it did before, it was a lot more stable than it was.